Anyway, that's what you're actually seeing there. I'm transmitting a signal on 1283, but because this SDR RTL dongle doesn't have enough bandwidth or a high enough sampling rate, I can only see part of the spectrum. This signal is actually 4 megahertz wide, so you're just looking at the bottom end of it at 1281. It's centered on 1283, and I'll just pop up, there's the other end of it, you see. So that's all I can see of it. So that's what a typical digital TV signal looks like when you look at
that.
Yeah. Yeah. You look in the middle of it, it just looks like noise. I'll come back to that later. And I'll carry on where I was last time. Because we never got through COFDM. So this is, oh, hang on. I've got to get this working properly now. I don't know if it'll start there. Maybe it doesn't start there. I'll have to go all the way down. This could take a while. DVBS. Oh, there we are. DVB-T. Right, so this is the system that's used on terrestrial TV broadcasting, used in Australia, used in New Zealand probably, used all over Europe, not used in America because they've gone off and done something different. And it's the whole motivation behind the way DVB-T works is to handle multipath. You remember with old analogue TV, you were forever moving your antenna around if you were like me and you didn't have a line of sight path to get rid of all the ghosts. Digital TV with COFDM, superb modulation, solves that problem. And it still fits this into the old 7 megahertz analogue channel. So on amateur TV, we're using both DVB-T and DVB-S. So I'm going to spend too long on this, but just so you think about what happens with the multipath. If you've got a path difference of 10 kilometres, say, direct signal, reflected signal comes along at extra 10 kilometres at the speed of light. That means over 10 kilometres, it'll take 33.3 microseconds for the delayed signal to get to you. So now think about if you're sending relatively high speed data over that channel, say 5 megabits per second, which is typically what you'd be doing with digital TV, that's only got a bit period of 0.2 of a microsecond or 200 nanoseconds. So when you work it out, one of those digital bits, as it's travelling through the air, will occupy a distance of 60 metres. So that's probably from about, I don't know, here back to out to the road, or a bit further maybe, something like that. There's one bit of data sitting in that distance. And if you've got 10 kilometres of path delay there, that's 166 bits of data sitting in that delay. So that all that data is arriving at you, of course, out of sync with the data that you want, because it's 166 bits later. So it's no good, it interferes with it. So COFDM gets around that problem by slowing the data rate down, essentially, and spreading it over multiple carriers. So with a frequency division multiplex, it's just like our normal radio bands or any bit of spectrum. It's all different transmitters usually sharing the spectrum on different frequencies so they don't interfere with each other. But in this case, all the signals belong to the same data, but they're now spread over lots of frequencies. And because you're reducing the data rate on each carrier, the bit period is getting longer and longer, and you can make it so long that you can start to ignore the reflections, basically. And they do that typically with a guard band or guard period where you say, I don't care what happens here, I'll wait until it's all settled down. I've got the reflected signal, I've got the direct signal, they've got the same data in them, they're adding together usually, which is really good, so I'm getting even more signal thanks to the reflection. But anyway, a quick calculation there says, well, how many carriers do I need to transmit for this to actually work? 10's not enough, because you can see it's only 33 microseconds of benefit. But here, if I start transmitting on 1,000 carriers, I've really slowed my symbol rate down. It's getting to be okay now because I'm at 200 microseconds per bit period versus my 33 microseconds of data. So it's bigger. But of course you can't actually have 1,000 carriers on 1,000 different transmitters, and it's all done mathematically, of course, which is where the a fast Fourier transform comes in. On inverse fast Fourier transform mathematically generates all the carriers, each of which in turn is modulated with QPSK or 16 QAM, quadriampere modulation, whichever one you want to use. So I won't bother too much with that, but that's a bit like an SDR, but that's sort of how you transmit something using OFDM, where your data gets serialized, spread out across the inputs on that big FFT. -1 is the same as IFFT. And IQ modulation goes out to the antenna.
So your typical TV receiver,
yes,
or TV dongle or whatever,
yeah,
will have an FFT,
yes,
1,000 point FFT running.
Yeah, in fact it's typically 8K, 8,000 point FFT used for normal terrestrial.
Right.
But 1K was an example just as a sort of a minimum.
And what sort of numeric precision is required on that?
Oh,
like 16-bit numbers, or?
That's a good question. I don't know if I know the answer to that one.
Probably depends on the receiver. Yeah,
look, I would have thought you'd get away with 8 bits, something like that. You probably don't need too much. As long as you can get a good enough signal to noise after you've been through all that processing, it's good enough, right? Because you've got...
add 8K into one bin, so you need
yeah,
a bit of headroom.
Yeah, but you've got all this error correction that's sitting on top of it. You've got trellis decoding, a Viterbi decoder, you've got Reed-Solomon, all that going on as well. So I don't know is the right answer to that, but I'm guessing it might not be as much as you might think. That's an example of a 64 QAM constellation with a bit of noise mixed into it. So the thing to look at here is just the fact that it's got 8 points that way, and it's got 8 points that way. That means you've got 3 bits on this axis, 3 bits on this axis. That's a total of 66 bits, 6 bits, sorry. 2 to the 6 equals 64, hence 64 QAM.
But you're not getting 64, 1 or 64, you're not getting 6 bits on every cycle, are you?
Yes.
Every cycle?
Yes, you're sending 6 bits per symbol. That's the way to look at it. I
don't understand how, within the bandwidth you've got, you can fit the extra data into that many bits per board. Because it's multi-level modulation, so you're getting more bits in. This, in each of these directions, it represents amplitude modulation. So whereas with QPSK you'd have only had 4 points here, you're happy with QPSK, aren't you, which is 2 bits per symbol. All you've done, you've got extra points in each direction, in X and Y. Phase in one and amplitude in the other.
These are 90 degrees apart, 2 axes, both of which are amplitude modulated. So that's different to what I said last time, which was the way DVBS works, which is phase modulation.
Right.
This is exclusively amplitude modulation. But there's a penalty here. You've got the problem in the receiver. You've got to work out, am I receiving that group of dots or am I receiving that group of dots? So you've got to discriminate. You've got to discriminate 1 of 8 points in that direction, 1 of 8 points in that direction. So you see, 64 QAM is no good for DX. We didn't use this on our TV repeater. We went for QPSK. It's obvious because we want to go DX. you only do this if you want to push up the bit rate.
And you've got
noise margin. You've got good noise margin. You've got millions of dollars to throw away on high power amplifiers to push out a really good signal. When you're sending out watts, you don't use this unless you're on a line of sight path. So there we are, as you were showing earlier, nice sort of square looking shape. That's a DVB-T spectrum. Oh, you can't see it on that one.
I'm sure I can, but I need to update the firmware.
Yeah.
An old version.
Okay. Good. Finished that bit. It's all hand waving practical stuff now. So I'm going to talk a bit about the TV repeater that we used to have up at Lawson. Unfortunately, we lost the site a few months ago. Absolutely superb location it was. Line of sight to Sydney. Enormous coverage. But all gone. But I'll show you what equipment we had up there anyway. And of course the hope is that sometime we can get it going again from somewhere else. Maybe even here, who knows. But we want to try and get it set up somewhere, because having a TV repeater makes a huge difference, because it's somewhere that's well located, that gives you a signal. If you want to set up a receiver, you can do all sorts of experiments with this sort of equipment when it's running. So you can see we had quite a bit of gear up at Lawson. We had a 23 SEM masthead amp and another shack preamp, because there was a fair old run of coax here. And we split off into a whole bunch of filters here. Quite important this, because these receivers over here, they're typically like this thing over here, like this satellite set-top box, and they're wide as a barn door. They're only intended to be connected through an LMB in your dish. They're not expecting to see all this other rubbish out of band, so you need to get some good signals into those receivers.
So the dishes use something like 1296 as a downlink frequency, do they?
Yeah.
Oh,
very convenient. Perfect.
Very convenient.
Yeah, covers 23 SEM amateur band with no modifications. So that set-top box there is receiving that transmitter over there with this little bit of wire just stuck out the back of it.
And it doesn't have a dish and an LMB on it?
No, nothing. So it's the easy way to receive. I'll show you this later. We also had up there, we had a 5.8 gigs FM receiver on 6 centimetres. And by the way, there's a couple of FM receivers here. So originally we started off at this one with 1250. This was our sort of legacy receiver. We only used to have that and nothing else. And the next thing that got added is this all migrated from analogue to digital. We added this 1283 DVB-S receiver. And then we added a 1280 megs FM receiver, which is using these FPV drone equipment. It's relatively cheap stuff that you can get on eBay. Runs on 1280 FM. And then later on we added a DVB-T receiver. So you'll notice here these are all on different frequencies. So this means we can more or less receive all of these at the same time. And we've had 3 of them going at once. And one of the features that we had on the controller was a split screen, so you could come up with a screen split into 4 parts, and you could see all 3 stations coming through at the same time. And we mixed the sound together so we could sort of talk to each other and see each other at the same time, which was a bit of fun. We had all of it controlled on 2 metre DTMF, because we had a 2 metre repeater up at Lawson, and so you would send DTMF in here to control the controller, although some of it was automated, and it could automatically poll round all these receivers, and if it found a signal it would start relaying it without doing anything. Originally that was an analogue transmitter, and it was a pretty easy job to just replace that with a digital transmitter. So you'll see here that's sending DVB-T, 7 megahertz, the standard system. And the reason for that is it's then easy to receive this. If you're lucky, your normal TV set might be able to pick it up, but you have to be pretty lucky, unfortunately, because a lot of them, they will only tune into the normal TV channels.
Standard channels.
Yeah, standard channels. And lucky I got one at home, a Sony TV, which covered 77 straight away. So I was pleased with that. Because you never know when you buy it, you don't know, is it going to tune it or not? You don't know until you try it. Right, I'll let you get the photo and then I'll move on.
So from trying to memorise the frequencies.
Yeah, okay. So, moving on. Now, luckily it was a VK2JPL's house at his shack out in the back garden. So, it meant that we didn't have to put it all in a rack, so we just had all the equipment on the shelf here. This is only some of it. So you can see all the array of receivers down here. That's the original FM receiver. That's the controller I built with the Raspberry Pi. All the filters up here on the wall.
That's manufactured filters? Or did you tune those yourself?
Yeah, they're all homemade. VK2ATU built up and tested and lined all those filters. He found a really good way of manufacturing them. So anyway, we'd obviously be able to sort of compact all this if we ever...
So you need that in a lounge room, eh?
That's it. I can show you photos.
Yeah.
Modern art.
Well, it made it easy, and it was a work in progress, which I really like, because we could keep adding different receivers and try different stuff out.
Up on the whiteboard.
Pretty much, yeah. It just sort of follows that. It follows that diagram there. You see, that's what it is.
I like the dozen.
Yeah. Anyway, we can always get it into a 19-inch rack with some shelves. That'd be the easy way. But you'd want to keep using these little set-top boxes as all the receivers. Because they do work pretty well, especially that one down there, that combo. Bit out of date now, but there's not so many of us were doing ATV, but we had a few, and we had a few people who were watching only and never got as far as transmitting. They just waited too long before it went off. I'll teach them. So, how to get started then? Now, this, of course, you can't do this anymore now, but you would have been able to go up on a Monday night and looked out for VK2RTS from Lawson. We had our net on Monday nights at 7:30, so you'd know for sure there was a signal on, and that'd be an opportunity to see if you could pick something up at home. If that didn't work, well, here's the thing. So, because TV signals are relatively wideband, you've got to be getting a really good signal on 2 meters. So that was the first thing that you could do. So when we had the 2 meter repeater up there, you could easily check that out with standard equipment and see how good a signal you're getting on 2 meters. You've got to be getting S9++, or you've got no chance with a TV signal, because it's typically 1,000 times wider than narrowband FM, so you've lost 30 dB straight away. Right, so that was a good guide. If you can get that really well, then you know you're in with a chance.
What about Caradrone for a site? Caradrone Radio Museum?
No good.
No good?
No, I don't think so.
Hasn't got the aspect.
No.
Caradrone Grass Cats is good, but there's another commercial sign up there. But I did a link with someone from there to Bella Vista and then my place.
No, the Radio Museum's up this way, I asked.
Yeah. No, it's. I don't think.
Days of Wi-Fi, it was probably a record.
Yeah. Now you normally need a high gain horizontally polarised antenna on 77s pointing at the Blue Mountains. So of course if you can see the Blue Mountains, it's going to work. and if you can't, like where I am in Ryde, I didn't have a line of sight path. I was lucky that it just came down to the repeater being at such a superb site that it was line of sight until it got to some hills near Sydney, and then managed to still get through some...
A little bit of refraction.
Yeah, a bit of knife edge refraction. I could get a signal where I was, because I live in a bit of an RF black hole.
You can potentially get something a bit below the horizon.
Yes, yeah. You have to look at the path and see if it's any good. And if you've got one hill in the way, you might be in with a chance. If you've got two, yeah, probably not going to work. Yeah, good 70cm preamp, like mini kits. I think yeah, that's right. They're not. They used to make them ready-made. I bought a few of these. They're brilliant. These preamps. They're very low noise, sub dB noise figure, and you have to make it yourself now. He's not doing it as a ready-built kit. SDR, it's really handy having this, because with the SDR you can have a look for the spectrum, and you'll be able to see the spectrum before your set-top box or your dongle or whatever it is can decode it, because it's going to have to be 5 or 6 dB above the noise before you'll be able to decode a signal, but you can see it on the SDR. So and then you can say, oh right, I got something here, I just need a bit more antenna gain, higher, whatever, and you might see if you've got a chance then. And what we got, all DVB-T. Yeah, well that's true. I'm glad I put that on. This is a challenge with this. So the problem with digital TV is you've got to be receiving a signal before you can even start to scan it, to decode it. So the signal's got to be strong enough. You can hit the scan button so that the receiver then finds out what's on the carrier, and once it's figured that out, you can start to decode it. So you've just got your set-top box and there's no signal on. Even if you try and say, if you've got manual tuning, go to 1283, or well, no, it'll be on 77's 445.5. It won't do anything. So you've got to be getting the signal. So again, that's where the SDR is handy. I mean, it was easier for me because when I started this, everything was analog, and I knew I was getting analog signal. We then switched to digital, and I knew I would be getting some sort of signal. It was just a matter of, is it strong enough to get a digital signal, to get a picture?
Looks like noise to me.
Yes, that is the challenge. So I'll just run through a few of the set-top boxes that you can get that do DVB-T. So this is what you're going to do if your TV won't tune into it. You're going to be using a set-top box, and there's a couple of examples there that I think they're not combos. They're just DVB-T/T2 receivers. I've got one of these. I can't remember if it was the 32 or the 34, and it's not a bad receiver. The 34, I think, was the one that got modified so that it would cover ATV. They did a special for us when it was requested. They changed the software so that it didn't have to just go to normal TV channels. But it proved to be a little bit deaf, that receiver. It worked, but it wasn't all that good. But yeah, there's a bit of experimentation. These combos were available on eBay when they first came out, and they do everything. T2, S2, they do MPEG-2, H.264. They don't do 265, which would be nice to be future-proof. And they're quite sensitive, actually. They work quite well, those boxes, and that's one of them down there. The only trouble with that is they used to also tune straight in on 445.5, no problem at all, providing you told the country it was, it wasn't Burma, was it? It was some funny country somewhere. Somehow we found this out. If you selected this country, it would then tune to 445.
Oh, I really am in Kuwait.
Yeah. Yeah. But they messed around with the firmware after that, and after a while you bought these things and they wouldn't tune in anymore. So that was a bit of a shame. Of course, there's a way around it. You can always put a mixer oscillator on the front of it and just shift the frequency from 445 to one of the normal TV channels so this thing can pick it up. And you can do the same thing, of course, with your normal TV. So it's another way of doing it. So, yeah, High Des, which is a Taiwanese company, they've got these black box receivers, and they're all designed for this FPV. So they've got a little tiny transmitter that people send up in their drones, and they transmit full HD DVB-T from a drone and send it back to one of these. So it's really superb. And
the competition drone pilots like analogue TV.
They do.
Because they don't get the lag.
The lag, yeah, that would be a problem. Yes, you're right.
Not Hessian up, but he's one of our members.
Yeah.
He's got a commercial drone pilot's licensing.
Yeah.
I've worn the second set of goggles while he's
Yeah.
flying through the trees and things, and you can really see how the lag would kill you.
Oh, yeah, yeah. So typically, I suppose people would be recording it in HD on the drone to get the full quality and
like
sending it
analog
analog.
TV, because if it breaks up,
Yeah.
you lose a few lines, but you don't lose the whole
Yeah.
picture.
Yeah. Yeah, that is the disadvantage with digital. It's all or nothing. So there's another option. Hydes have got these dongles that you can put on your PC. I've never tried any of this stuff, but you can see it covers 70 SEMS on there, and it covers 23 SEMS. Just go straight in. So you have to choose which one you go for, the normal standard bandwidths, or you can experiment with some narrow band DVB-T. And then you've got to be able to receive if you're transmitting DVB-S rather than DVB-T, you'll need a DVB-S receiver. And so that's one example of a homebrew one, which is a kit that's made by the British Amateur Television Club. And I'm going to show you this working later. There's a brilliant bit of software that comes with it.
That's a bog standard down converter, isn't it? Sold on the board there.
It's what's called a NIM, and I remember what that stands for now. It's a module of some sort. This is more than a down converter. It's got the whole DV. This puts out a transport stream.
No.
So it does the whole decoding, receiving, down converting job in there. It's got some ST chips in it. But I think these are just about running out now. This is the problem. It's getting very hard to get these parts now. I've got one here. You can actually see that there's that NIM, that module. This is the small version. So the Americans came out with this. This is the what do they call themselves? DATV Express. So it's got that same module just sitting in there with all the electronics on top of it. The French guy who designed this originally, he didn't like that because this does get a bit warm. Whereas this is pretty big and it sort of spreads the heat out that's coming from these regulators mainly. But, oh yeah, of course there's a picture of it there, but there's the real thing. And as it covers all the way from 2 meters up to 2.4 gigs with this tuner, so it's dead useful. I'll skip that because I'm going to give you a live demo of that, but that's what it's going to look like when I do it. This is what I used to have. I've still basically got this, but at my place. So I've got this is 70 SEMS coming in here. Goes through a distribution amplifier, which means I can send it off to a whole bunch of different receivers at the same time, including the TV. Also goes into a line mini SDR. So with my setup at home, I was able to compare these different receivers all working off the same signal. So on my Sony TV, these are all feeding on HDMI back into there, and I can do a split screen on the telly, and I can look at two receivers at the same time, and then you find out what the difference is in performance between these, and it's quite significant actually. Not all set-top boxes are the same, right? So in terms of the sensitivity out of these receivers, the Strong and the Sony TV perform the best in terms of sensitivity. I was surprised actually. I thought the combo was going to do better than that. The GT Media was the worst out of the lot in sensitivity, and I'm talking 3 or 4 dB difference in signal to noise to get a picture on that versus on this, for example. The Line Mini here, I'm using that as just as a spectrum analyzer, if you like, so I could look at the repeater signal that we were transmitting from Lawson and check its spectrum out, looking at it on the Lime, and some software running over here, SDR Angel, I think I was using for that.
But you didn't run any decoding software on that? Didn't run DVB-S or DVB-T decoding on that?
No. So the SDR Angel can decode DVB-S, can't do DVB-T. It just needs too much grunt. It's just too much processing to do for DVB. You can imagine you've got to do that big FFT and fast. Yeah. So yeah, it's not. You can do it, but it's a challenge doing all that in software. So he hasn't done it yet anyway. I mean, here's the thing. Maybe there's not much incentive for him to do it, because it's another French guy who wrote that software. Everywhere in Europe, everybody's using DVB-S. They're not using DVB-T, not for amateur TV, and there are good reasons for that. So yeah, probably not a big enough market for him to put the effort into do a DVB-T decoder.
There should be plenty of CPU grubs built these days, so.
Yeah. It should be possible, yeah, with a bit more CPU. But his DVB-S decoder, it doesn't work as well as the NIM module. I've done a comparison of those two together, and it needs 5 or 6 dB more signal for that software decoder to work. So he's probably taken some shortcuts maybe in his decoder. He hasn't done his error correction as well as he could have done. He could take some shortcuts there to cut down CPU effort. I don't know, but in theory it should work just as well, but it doesn't. Now, on the transmit side, of course, you'll have to decide, well, am I going to transmit on 70 SEMS or transmit on 23 SEMS, or both maybe? This is the British Amateur Television Club's ports down system, just showing the menu system for it. So this all runs on a Raspberry Pi. It's phenomenal what they've managed to pack into a Raspberry Pi, and they're still adding features to this. So this will be the Pi 4 version. I'm still on an old Pi 3 version at home. I haven't even got the screen. I didn't even bother with that. I just talk to it through SSH all the time, because I don't need to talk to it very often, because I just sort of set it up. I want to transmit on this frequency, this symbol rate, that's it. Just when I turn it on, do it. I don't have to keep configuring it every time. I just want it to just come up as is. So I never bothered with the screen, but nearly everybody does, which is useful if you want to do other stuff and play around with all the options. But this system supports DVB-S and DVB-T. So this is what I use on transmit. But I run it with an incoming transport stream, which is a slightly different way of doing it. See here, it's got the easy cap. I don't know if you're familiar with these things at all, but they're little USB dongles that you can plug into a computer, which will take a composite signal, PAL plus audio, and then it digitizes it that makes it look like a webcam. Yeah, it's video capture, and that's
analog video capture.
It's analog video capture, yeah.
Because we're about to put a digital video capture
Yep.
card in for AV here.
Yeah. Yeah, so they've tried very hard to get this ports down, which is using a Raspberry Pi, to work with an HDMI capture card, and they haven't had much success in doing it. It's just proved too hard to get this to work on a Pi. Seems to be a problem with drivers and stuff. I wouldn't go near it. Hence the interest in doing it with a transport stream, because then you can get round that limitation.
It could be just crappy software, because I had an easy capture card and that was a piece of crap. That was right.
You and me both.
Yeah.
Yeah.
Ah, they're diabolical.
I've had easy caps running on about 3 different computers, and they've all worked fine for me. No problem at all. But I'm glad I'm not using it anymore, because the quality is just not there, of course. But that's a simplified block diagram of a Raspberry Pi ports down system. So actually there's a Pi camera as well, and a lot of people, that was a really simple thing to do. You just connect one of these Pi cameras, like a webcam thing, straight up to your Pi, and you're on the air. You don't need anything else really. Well, apart from an SDR. In an earlier version of this, by the way, they didn't even have an SDR here. This was all analog. So the BATC developed a D to A board with a whole bunch of analog filtering on it. You know, it was the old school method of doing it. It worked quite well, but of course when these SDRs became available, it was definitely the way to go. Else you get rid of all the analog then. But there's this thing over there showing the easy cap. And Mini Tuner, you can hook that up and it acts as a receiver as well with the same software. So it's pretty useful, that. Now here's another way. Well, here's one way of generating a signal in DVB-T on 23 SEMS. So John ATU did this, and he based it on work that they did down in South Australia, mainly VK3 VK5 triple Y, I think it was. YYY. So how this works is you can go out and buy off the shelf these DVB-T modulators, but these typically only cover the normal TV frequencies, the normal TV commercial channels. So what they're used for is TV distribution systems. So you'd have one of these in a shop, and they'd send all this DVB-T round for all the different TV sets. So then they've got all the promo videos running in all the TVs in the shops, etc. Or they're used in hotels, so they send in digital signals around in hotels. But they won't work on 445.5, unfortunately. But of course you can get round that. You just have an oscillator with a mixer, shift it up to the TV band, wherever you want to go, 70 SEMS or 23 SEMS, and you're on the air with that. So that's what John has been using. That works extremely well, because they've got moderately good encoders in them, but not that good.
What sort of frequencies coming out of that? What sort of signal frequencies coming out of that modulator?
Oh, I think he runs this at about 500 megs.
Mm-hmm.
And then he mixes it up to 1287.
Yeah, so your sideband,
your
spurious images are well out of way.
Yeah. Well, that's and you've got to clean it up, of course, because that's what this bandpass filter's doing here, to get rid of any funny products that still get through the mixer. We spent quite a lot of time actually, because we needed a decent DVB-T modulator for the repeater. And we looked at a few of these, but because it was important for us to get DX out of it and use QPSK, that meant our bit rate was quite limited. We couldn't run at more than 5 or 6 megabits per second. And these modulators are hopeless at that bit rate. If you try and get high compression out of one of these, As soon as you move, the picture breaks up, it freezes completely. They're hopeless, right? The encoders are not up to the job. So he gets away with it basically because he's running it at a fairly high bit rate, because he's got a good signal path up to Lawson, or he did have, and he could run at a high bit rate, me taking advantage of the fact that his signal to noise was so good that he could use one of those big constellations. He was using 16 QAM, which is not so big, but you can get away with it. Then you don't have to run the encoder so hard. But we needed a decent modulator for the repeater, so we went out and spent some money on one of those high-des modulators, which does a reasonable job at a reasonable bit rate. They're still not as good as you can do, you know, if you really work hard on it, but it was good enough for our TV repeater. And it worked pretty reliably. So that's one way of transmitting. If you want to go for the sort of bolt together black boxes, you can go out and you can buy everything on that diagram except for that filter, and you have to make one of those yourselves. You might be able to buy something if you can get it on the right frequency, but that's a home construction job for that. This is a good thing about amateur TV. You generally can't just go out and buy a black box. You have to build it yourself. So there's still a lot of experimentation goes on. So there you are. That's what it actually looks like. And that's that off-the-shelf modulator. He's got a Blauhaus one. And the bits and pieces in there that were on the block diagram. There's another one of John's filters. And he's got a 5-watt amplifier on the back there, one of those Mitsubishi brick modules to get a reasonable amount of RF out from it. And you need, with DVB-T, you need a really linear amplifier. So this is the problem with DVB-T. You've got a crest factor, which is the peak to average power on a DVB-T modulator of at least 10 dB. So that means if you wanted to get 5 watts average power out of this, you need at least a 50-watt amplifier to handle the peaks. Hence, DVB-S is much easier to transmit because you can get away with a much crappier amplifier, basically.
1,000 signals, sometimes they're all going to be in the same direction.
That's exactly right. That's what happens. Sometimes they're all in phase and then you're in trouble. There's a bit of trickery to try and minimise how often that happens, and you can do things by adding pilot carriers and tones and have blank missing carriers and things like that to try and reduce the crest factor a bit, but it's basically inherent to that modulation. So that's John's setup. Now let's talk a bit about another way of getting on the air. So this is called DATV Easy, and this software is another. The French have really produced a whole load of stuff here that's used by everybody, and this has made it so much easier. So what he's done with this software, there's a lot of stuff going on behind this. So you need a front end to it, so you use something like OBS or vMix. I'll show you those bits of software later, but OBS is free, you'll be glad to hear. And it kind of then looks like a webcam output. You can put a virtual camera out from OBS or vMix, and then that becomes the input to this software. So that's your video going in. This software then does the H.264, or in fact it does 265 as well, does all your image compression, and it does your modulation, DVB-S, DVB-T, in one sort of handy bit of software. So I've got this running at home, and it does a pretty reasonable job, but it is sort of aimed at beginners, if you like, because you don't have much control over it. I prefer to do it the hard way, which is writing a very, very long FFmpeg command line where I've got control over all of the parameters and I can really optimize it which you can't do with this. So I found, yeah, it works fine. It's dead easy to get this going, but the quality not quite as good as you can do yourself if you work on it pretty hard on the encoder with the software. But it's good. It's good enough. Most people will be pretty happy with this. Now on the output side of it, you do need an SDR. So it's the Lime SDR again, or it runs with a Pluto, and it does do the narrowband DVB-S modes, which is very useful. It doesn't do 7 megahertz wide DVB-T. It only goes up to 2 megahertz wide DVB-T. So if you transmit DVB-T with this, you're going to need a narrowband DVB-T receiver. But yeah, no, yeah, you see. In fact, there's a new version of this. I've downloaded it now. I haven't fired it up yet, but it actually now supports H.266 in software, and he even gives you a plug-in. If it's a plug-in, I think, for VLC. So you can then decode the H.266 with VLC as well. So some guys in Europe have been playing around with this. Of course, you know, it gets really interesting with H.266 because you've now basically gained another 40% in terms of bitrate reduction for the same quality. So you're starting to be able to get some pretty good quality pictures now with some really stupid bit rates, stupidly low bit rates, that is. Yeah, okay, so mini kits, yeah, they've got some good stuff. So, of course, you've got to boost up your power, so sort of jumping back to transmit again. These SDRs, they're typically only generating a milliwatt or less, so you're not going to get very far with that. That transmitter I've set up at the back of the club here is running about half a milliwatt. So it's probably going about as far as these trees here, and that's about it, I would think. So to get that power up, you need something like this, and you can put a few of these in series if you need to get it up a bit more. I've got a couple of these I run in series before I get into a Mitsubishi brick amplifier, or it's a double brick amplifier, in fact, for 23 cents. And yeah, they're not too expensive. And then, of course, you've got to get a decent bit of power out. So when these Mitsubishi bricks came along, it was just magic. They just made it so much easier to get going. Because prior to this, everybody was trying to get little discrete amplifiers working. There was all home-built stuff, and they were a nightmare. Keeping those things stable, not oscillating all the time. Real problem, but this made it dead easy. Can I just check what the time is, because I don't want to go too long. I'm okay. It's 9 o'clock. Yeah, 9. It's good. So there's your your preferred method of getting some power. Try and get hold of these bricks, but they're getting a bit hard to get hold of as well now. But you can still get them. I think Mini Kits has got a few of them down there. You might be able to get some from down there still. If not, it's back to discretes, unfortunately. But there are some people in Europe who are making some really nice... oh, there we are. I didn't know that was coming up next.
You see them at AliExpress for $90.
Yeah, that's good. Hope they work. Got to be careful.
Well, they probably pulled some equipment.
Yeah.
I've got a 300 watt amplifier plug-in.
You got one of his?
300 watt one.
Yeah, Bert Moderman stuff. It's magic, isn't it, the way it's built? This is real engineering. This is brilliant engineering. I've got one of his filters actually on my transmitter as the clean-up on 23 SEMS. I haven't got one of these yet, but if my modules pack up, then I'll have to get one of these in, I guess. Yeah, it's starting to get a bit more pricey now, and of course they do need a 28 volt supply now instead of 12 volts or 13.8, which the bricks will run on. But yeah, you just have to sort that out. But yeah, this is... Of course, this needs a big heat sink, right? This is 150 watts. If that's 150 watts RF out there, you've got about 300 watts here. I don't know, yeah, they're not so efficient, these things. So you've got this on a really big heat sink with a load of blowers.
Class A, won't they?
They're what?
They're not going to be living enough unless they're really Class A, aren't they?
Yeah, well, that's true, but of course you always push it as hard as you can go, right? Because this is where you need a spectrum analyzer. So when you're putting your signals through these, you know that nice square-shaped signal, well, it doesn't stay like that for too long. If you start pushing it up, you start getting replicas of the spectrum starting to come up at the sides, so you'll start to see, you know, it's coming up here. But 40 dB down is nice. 30 dB, yeah, that's probably pushing it, but that's what most people end up with, because, yeah, I've got to try and get a signal out somehow. There's not much benefit in, if it gets much worse than that, you're not actually winning anything, because what will happen is you'll think, oh, I'm sending more power, but no, what's happening? You're distorting the constellation. Those points, they're moving around, they're not where they're supposed to be, and if they go too far, you're corrupting the signal now, and there's no point, you're just wasting your time. So you've got to keep it linear and keep an eye on the spectrum analyzer. So, okay, I'm moving on now. Do you want to ask me anything about the stuff I've shown so far before I sort of jump to a bit of a different subject? How big a heatsink have you got on your 300 watt amplifier?
It's got a lot of fins.
You've got a lot of,
fans behind it.
yeah, some big fans. And how much DC input are you putting into that?
It runs 28, 29 volts at lots of amps.
Lots of amps, yeah.
All the
Lots of amps, yeah.
So, after when you start up with this, you probably like me in the old days, you just got one camera and that's it. You just sort of move the camera around, that's all I can do really. And pretty soon you think, oh, no, that's a bit boring, I'm going to have to get more than one camera. And maybe I'm going to need a bit more stuff. As soon as I get more than one camera, I'm going to want somewhere switching them. I don't want to keep putting the plugs in and out. I better get myself a switcher and a mixer, do it properly, and then I've got to be able to show some videos. I need a media player, and now I need a few computers as well, because I want to show people stuff like I'm doing here on the screen. And then I want to make my own videos on editing software, right? And so it goes on and on. So you can spend, and you do, and you will, spend a lot of time on this aspect of it, rather than once you've got all the transmit and receive sides sorted. This is the next area that you're spending all your time, getting all the production stuff, the live streaming and live production stuff all on the go. And you're going to need some more video capture devices. Yes, you'll like to have a green screen as well, so you can do some really nice chroma key. I've got this at home and I can sit in front of my green screen and I've got a picture of the Opera House behind me, or whatever else I want to put up there. So that I can show off the fact that we live in Sydney and this is where everybody should be living, you know. Come here, this is the best, especially when we're sending pictures down to Melbourne, right? Yeah. So, yes, streaming software, I mentioned that a little bit before, and this is the thing where you're sending pictures over the internet now. And you'll want a bit of software to do that, and we've got this absolutely brilliant BATC streamer that I'll get onto. SDRs I mentioned, yeah, very handy if you've got one of those to see what your signals are doing. So this is what I've got on a transmit side. So I've got one of these A10 Mini Extremes ISOs now. So this is an 8-channel mixer. There's all HDMI inputs coming in here. So I can connect 8 different sources up to this, and I have got 8 different sources all connected up to this. I've got a mini one of these as well. I've got the 4-channel input as well, the 4-channel ATEM. We've got the computer sitting over here, which is doing the streaming out to the BATC in the UK or wherever it's going, or down to Melbourne. We're capturing the video out of there, and the deck link has gone now. I've changed this to a dongle, but anyway, another computer. So I mentioned I'm generating a transport stream into my Pi 3. This is how I'm generating an HD signal running FFmpeg on this PC over here. And that lets me send an HD signal then out through the Lime Mini. And that's how I generate 1283 HD on DVB-S2. And of course this means with this I can move this around. I can put this onto 70 SEMS, and I've been doing exactly that recently.
Speaking of Melbourne, have they got a TV repeater down there?
Oh yes,
More than one?
more than one now. They're just getting a new one up and running at Geelong.
Just know that some of my gear I've got in my shack is from an SK from 15 years ago.
Yeah,
He had a room, his whole shack was full of cameras and video equipment.
there's a lot of guys. There's a big group of people doing ATV down in Melbourne. They've got a really good location for their repeater. I think they've probably got reasonably flat terrain. They don't like me saying this compared to us in Sydney. I mean, we just got so many hills here. It just makes it so.
Probably just got someone sitting up the side of that down and beaming out the whole of the city.
They're at Mount View now.
Where?
Mount View. So they used to be on the top of the Dandenongs, but at the Linda, but they lost that site, and it took them a couple of years to find a new site. But they've had a huge amount of help from Amateur Radio Victoria. They're very pro ATV down there, and they've helped them, getting the site, and it's a brilliant setup down there. I mean, we had a really good setup here, and it was so sad when we lost it, because now we've got nothing in Sydney, and somehow we need to get this back on the air in Sydney, so that, because they're just treading us into the ground in Melbourne, basically, with the lack of a TV repeater now in Sydney. It's very restrictive as to what we can do. So, yeah, really hope we can get it going again from somewhere soon. Just showing you some of the software. This is the ATEM, so you can get this up on your laptop. So you can remotely control the ATEM, and you get the whole control panel now working in software. So you can see I've configured it here. I've changed some of the names here, so that it says, WD, which is the WD media player, and the laptop, and the Raspberry Pi, and 4 cameras, and whatever, blah blah blah. You can configure it all, and HyperDeck. So that's a fancy name for a media player, if you like, and that's just an example of OBS software.
Tommy one.
The what?
The English one.
The English one. Oh, what, the test card? You mean?
Yeah.
Yeah, that's that's the BBC test card F, actually. Because of course I'm from the UK originally. But these are available sort of online. There's lots of pictures of these, so people just download them, edit them a bit, put their own call sign on it. You can take the circle out there and put a picture of you in the middle of it if you want to. Whatever, just as an example. So I was saying that earlier. There's my nice picture of the Harbour Bridge, which I can sit in front of with the chroma key, and I even downstream key in a few Christmas decorations when it's Christmas time. So that's OBS, free software, and vMix. I used to have the free. Well, I've still got the free version of vMix, but the problem with the free version of vMix is it only supports standard definition. If you want to do HD, you've got to spend some money, and so I didn't bother to spend the money. I just went for OBS, but other guys have. I really like vMix. It's a different concept to the way OBS works. It does things in a maybe more intuitive way. Some people find this easier to use.
Mount View repeaters only 2 kilometres from our house down there, and we've got a bloody good outlook from there, actually. Which
repeater was that?
The Glen Waverley one. Mount View is in Glen Waverley.
Yeah, that's where it is, I think.
Got a house in Mount Waverley when we're 2 sons live.
Ah, yeah.
up on the hill there too.
Yes.
So plenty of, actually, I can see Mount Down, I can see Macedon from our site.
Yeah.
So it's got a pretty good outlook.
Oh yeah, yeah. I've seen some pictures of the views from up at that site. I mean,
No,
they're
this is where our house is nearby
yes,
on Essex Heights. But
yeah. So, no, they've got the same. Well, it's a different location, of course, to where it was up at Mount Dandenong.
it's 2 kilometres west of where my place
Yeah,
is.
but they're still able to cover pretty well everybody who was getting it before. Yeah. So what, you've got another place in?
No, we still own our house in Melbourne.
Okay.
Because I moved from Melbourne.
Oh, right.
12 years ago.
Ah,
And my son still lives our house down there.
Oh,
It's
got
actually
you.
Up on a hill
got you.
in Essex Heights
Yes.
with a view of the bay and
Yes.
Mount Macedon.
Yeah,
and,
yeah,
and
yeah, yeah.
Downlands.
Yeah, nice.
So it would be a good site.
Yeah, it would be a good site. But we need you to move your house and that good site up here then.
Yeah, that's right.
It's no good down there. Not going to get
And they've already got one nearby up there anyway. So.
not going to get any signals from Melbourne up here. I don't think ever.
I've got a friend, Cohen Vandenveld,
Yeah,
and he's gone back to home to the Netherlands where he comes from.
yeah.
There's one tower that they've got there that they can cover the whole of the
Oh,
Netherlands
yeah,
and
well,
to Europe.
Well, it's
Yes,
flat.
flat. I know. I've been there. I've seen it.
It's a tower, it's chocker. It's got
Yeah,
lots and lots of digital TV stuff.
Yeah, yeah.
Heaps of repeat
And what the
stuff.
Netherlands
Yes.
is nearly as big as Sydney, isn't it?
So
now
it's a great town.
it was always the holy grail of amateur television. We all dreamt, when I lived in Europe, of course, in the UK, could we ever get amateur TV up on a satellite?
Oh.
That'd be brilliant. And it finally happened with QO100. I don't know if you know about this.
Yeah.
Yeah, some people do. So it was put up by yeah, the Saudis, I think, something like that, and they've got 7 or 8 megahertz of it sitting on that satellite. That's just there for amateur TV. It's absolutely brilliant. This has changed everything in Europe. So pretty well everybody's on this now, of course, and I mean, I think therefore all these terrestrial TV repeater networks all gone a bit quiet now, I suppose, because everybody's doing this, because it's magic, right? And you can watch this because some of it gets streamed on BATC when they're using it, and they have a net every week where they all come up and they're all chatting on QO100. The amount of development and experimentation that's gone on in Europe as a result of this is phenomenal, right? Because it's like when you've got a TV repeater, everybody's working on stuff at home to try and develop equipment that will work with the repeater. Now they're doing it to work with these satellites. There's been a lot of innovative stuff done with people in Europe on this. It's just magic.
It's just a single channel.
Well, it's an 8 megahertz channel, which means you can fit in a whole load of TV channels at the same time. You don't have to. They don't. I mean, this is all narrowband stuff now, so it's typically 333 kilo. It's all DVB-S, by the way. Nobody runs DVB-T on this satellite, but you can get about 8 narrowband DVB-S channels in here. And more even smaller ones. I haven't got a picture because there's a live scanner that you can go and watch on the net. You can see exactly what's happening on this wideband transponder all the time. As well as the narrowband one, you've got an SDI. You can go and listen to all the stations. You know, with typical SDI, you can just manually tune it all from home. You can listen into whatever you want to.
And the beauty of that satellite location is they haven't got any interference in the USA.
Well, that's true. But unfortunately, we're over here, right?
Yeah, well,
I mean, they could move it that way a bit, move it along a bit, then they could just about cover Europe, UK and Australia. But of course, that's how.
Canary Islands might complain though.
Yeah, they wouldn't be happy. And this is good for them.
Our phones were on the edge.
Yeah.
Yeah,
Now, I thought this too, you see. I looked at this map initially and thought, yeah, okay, it's no good, there's no coverage here. But hang on a minute, it's not quite right. When you look on the map here, How about this? Christmas Island just makes it inside the footprint, would you believe? And that's VK9. Now, this has already been done on narrowband. Somebody's been up there with a dish and they've worked VK9 on QO100. But ATV has not yet been done. It's still there as a challenge, right? The challenge is to build up all the gear. You'd need something like a 1.4 metre dish to do this. You'd be pointing it pretty much along the horizon because the satellites, you know, you're right on the limit of the coverage. So that means you're going to be subject to tropo and all sorts of weird ducting and stuff happening over the sea.
And also all the thermal noise of the Earth.
Yes, that's not going to. Yeah, that's not going to be good. But in theory, it should work with the right equipment. And of course, it's a bit of a challenge for us over here, building the equipment and proving it works when we can't receive anything. Yeah. And it's a bit hard, bit late once you've got it over here. I guess there's not much in the way of electronic shops you can go to. Is there on Christmas Island to get a few spare bits? No. J-car? So, yeah, interesting one, that. Somebody will do it eventually, but it'll probably be somebody from Europe will come down here and do a sort of a de-expedition. I expect that's what will happen. But it's going to be done someday. So, other recent developments, apart from the satellite, which changes everything for those guys. The other stuff, of course, there's all really the Europeans that are doing all the work here. They've been doing a lot of work on RB or reduced bandwidth TV. So in the UK, 2 metre band only used to go 144 to 146. All of a sudden they said, hang on, you can have another 2 megs here. And then of course they realised, well, we can get TV into that now. There's enough space. So in the UK, everybody's transmitting TV on 2 metres now. HD TV this is. In 333 kilosamples per second or so, DVB-S, which takes up about 500 kilohertz bandwidth. Of course, you need a really linear amplifier now to stop this spreading down into this bit, otherwise the narrowband guys will get a bit upset.
And a good receiver to stop the pages getting in.
Oh, yes.
Killing you too.
Yes, indeed. Which are just outside the band.
52 or something.
Yeah,
like that.
just up here. So
there's always a problem with fox hunting on 2 megs.
Yeah. There's some experiments been done on reduced bandwidth DVB-T as well. That's less than 1 megahertz DVB-T. And the BATC have come out with a special receiver called the Knucker for some reason. It's a bit of a strange name. I know it means something. Yeah, I don't know. Yeah, no. Yeah. You could be right if it doesn't work, but yeah, that's what it's called. But yeah, it's a special, another custom or homebrew job you can do to pick up narrowband DVB-T. And really getting silly now, very reduced bandwidth TV. It's compressing DVB-S now down to 18 kilosymbols per second. And I think I've got the CQ TV here, which is the one that's got this picture on it, which is the world's first time this was ever done, which was Rob M0DTS in the UK, sending a signal on ATV transatlantic to a Kiwi SDR over here, which had enough IQ bandwidth on it that he could get the stream back there as IQ and decode it back in the UK. So that was the very first time that was done. And they've now, of course, had actually people sitting over there who were decoding the signal, but that was the sort of proof of concept, if you like. But that's quite an achievement, that is. Of course, they were sending, that was the resolution of the pictures, so we're sort of talking here like slow scan TV quality, few frames a second, but they did manage to get it to work. They've got a recording somewhere of somebody just walking across the shack, and propagation was good enough just for a few frames of somebody moving in their shack to get through. But this is the sort of nature of this. It's pretty tricky stuff. BATC, I have to get on with it, won't I? There's so much to get through. This is the problem. There's so much going on. But the British Amateur Television Group the club is really where pretty much the centre of all the action of ATV, and a lot of it happening in Europe. But anybody who's serious in ATV is a member of the British Amateur TV Club. I've been a member of it since about '74 or so when I started on ATV.
Gary, that's not going to come out on the camera, but maybe you'd send us a slide deck we can share around the club.
Yes.
It's too small to come out on the camera.
I've got all the slides as a PDF file,
That's fine.
which I've got on a dongle with me. Can we?
That'd be easy to mail it to us.
I can. Yeah, it might be.
Not possible.
It might be a bit big. I don't know because I've got a lot of pictures in it. You see, I've got it. Have you got anything I can copy it onto here? No, probably
I
not.
don't.
There's no laptop, no computers in the shack here.
There's computers.
Yeah, potentially, but yeah, we can do it another time maybe because it's going to get a bit late otherwise. But yeah, they have this magic magazine, by the way, which I've just shown you. So the BATC streamer, you can go on here and now you can see TV repeaters all over the world. Those which are streaming. We used to stream ours on here when it was on an occasional basis, but you'll also see the Melbourne repeater will come up here, or in fact they've got 2 channels here, because they're about the only repeater that's got 2 channels that run concurrently. And you'll see different stations come up and go off here from time to time as these TV repeaters come up, so it's an easy way just to go off and see what's going on. Bear in mind the time difference, of course. So now, unfortunately, you've got to get up pretty early in the morning if you want to see much happening over in the UK. There's a good place to start. That's a multi-view of the BATC streamer. So I wrote a little script which I published in BATC magazine, which was a way of you then being able to watch. Instead of just sitting there looking at a list of call signs, you could actually start watching a lot of the streams that were coming out of BATC at the same time. And this is dead useful actually, because I just turn this on. I can have a look, right, something's happening on one of these repeaters, I'll go off and watch that now. So, yeah.
So that's an FFM picked up thing, is it?
Yeah, it just runs an FFmpeg script, and these are all little FF play windows. And this line sets itself up. You just set it a bunch of parameters. You sort of say, well, I'd like this number of little pictures across a row. I want to fit it in this amount of space on my screen. So you can make this really tiny if you want to, or spread it all out, whatever you want to do. Have any number you want on there. Be careful though, because if you're watching this many streams, you're probably pulling about 12 megabits per second out of the server. So they prefer that not everybody does this at the same time. It might get a bit unpleasant. Just getting towards the end, I think there's a few screenshots there. This is shots off of our TV repeater when it was running. Just a few people that were sending some pictures when we had it running. That was Paul, who's unfortunately silent key now. But you can see in the background there's that shelf I showed you earlier. That's the TV repeater in his shack. So that was Ray VK2ME he was talking to there on his old CRT monitor up there, which he got rid of eventually. So I've got a little handout which has just got this on it, which is a few extra little places you can go to on the web to get a bit more information. That's it. So good. I finally made it to the end. So I've set up a live demo here because originally I was only going to show you those slides. But the club said, no, hang on, you've got to try and do a live demo. You really wanted to prove that it does actually work and this isn't all fiction, right? So that's what...
You can see us up on the TV, right?
Yeah, so what I'll do, because I'm showing you the picture, that's the picture that's coming off the set-top box, and I can put that up on the projector as well. But I can also show you the mini tuner, because I've got that hooked up here as well. So I'll fire up the mini tuner, because it's sort of easier while I've got the computer connected up.
Lots of French spelling, something that sounds like tuner.
Yeah.
That's exactly how they write it.
Yes.
Tuner?
Mini tuner. Now, this is a really nice bit of software. So, what he did, his first challenge was to try and find a tuner with a chipset in it that would give him access to some internal signals. So you'll see what's going on here. Not only is that NIM tuner providing you with a transport stream, which is how we can see this picture here, which is coming from that camera, he's also at the same time getting out from that tuner the internal IQ signals, which enables him to display this live constellation. So if
See how clean it is.
now you see this number down here and this number over here. This is the important thing. This is your carrier to noise modulation error rate, and you see it's a pretty good signal at the moment.
So if I throw this antenna around.
Oh, I can move my end around as well.
Whoa.
There you see, you've lost it completely there.
I'm just waving it around.
Yeah. Now put it back down again. I'll wave it around at this end. Oh, you haven't found. You're in the bad spot now. It was. It doesn't matter. But don't. Is it? No, it was better before. It was D22. Never mind. Doesn't matter.
That's good.
What's good?
There you go.
Yeah, that's all right. That'll do. That'll do. As you can see, just walking around the room is having a big effect on it. But I'm just receiving it on that bit of wire, right, which isn't even a quarter wave. It's these tuners are pretty deaf though, but you get the idea. So you can see it's QPSK, carrier to noise, MER 25 dB. That's a very respectable signal.
The constellation was quite noisy.
Oh yeah, well it's a live. This is a live shot of what it's receiving, right? So if I move this around, you see,
Wow.
you'll see. Yeah, it'll just it'll get very noisy. I mean, but
But the picture doesn't seem to be changing.
Yes, it is.
it'll stop completely if. Hang on, if I pull that out.
Where's my hand?
Stop now. Yeah.
Right, look, we're down. We've almost got no signal now.
It's very correcting.
You see that constellation? It's nearly all noise now,
And it's still a signal.
but it's still getting it right because.
Mind you, it's there's nearly a second of lag on the picture. From
Yes, that is exactly right. That's the important thing. So,
So if I do that, my phone's back in my lap.
can you hear that?
Yeah.
listen.
Delay.
That's your encode decode delay, and of course when we used to run on analogue on the TV repeater, it was dead easy. We could talk to each other with no delay, and then once we started going digital, everybody was getting confused because of all the delay. So first of all, we only had a transmitter, so there was a transmit delay, but then when you're transmitting digital to the repeater, you've got to encode it, decode it, encode it, decode it.
But you're not recompressing, you're just decoding.
Oh no, yeah, we are. So
Compressing at the repeater.
yes, absolutely. You're not just sending a transport stream from a transmitter to a receiver.
That's a shame.
It is a shame because that would be a nice way of doing it. Except it'd be quite tricky then to do anything else because Doing it through HDMI means you can put it through switches, and you can mix video in. You can do all sorts of stuff once you've got it bound to video. You can't do that if it's still a transport stream. So whilst it's more delay, it's just a bit more practical to. And then of course all the equipment outputs HDMI. It doesn't output a transport stream. So yeah, just by word of explanation. You see here, because it's running on QPSK, it's got an FEC of 2/3 at the moment, it only needs a carrier noise of greater than 3.3 dB. So this D22 here, that's the difference between 3 dB and whatever the current MER is. So that number there, providing it's greater than 0, is telling you how much margin you've got. But what I was showing you earlier with no aerial connected, so there's another way I can do this. That's a dual input, that tuner, so if I switch that to the B input, which hasn't got any antenna on it, no, it's not getting anything at all now, we've lost it completely. It's just holding the last picture, you see, it's frozen, so it's not actually receiving a picture now. So I'll have to go back again.
And you can see the noise on the waterfall frequency diagram there too.
Yeah. Yeah, so as you can see, it's a really useful bit of software, this, because you can see exactly what sort of signal you're getting, and if you've got interference, you can see how it's having an effect on this constellation as well.
But only does DVBS?
Yes, this only does DVBS, this software, but what it does do that this set-top box doesn't do is it will go down to very low symbol rates. These set-top boxes, they'll typically only go down to 1 megasymbol per second. This, as you can see, it goes down to 66 kilobits per second. And so we've been playing around here in Sydney to try and get direct signals, because now we haven't got a repeater. It's a real struggle because there's so many hills in the way. But we have succeeded, myself and John, over an awful path of getting a signal through on 333 kilosymbols per second on TV, whereas an FM signal over the same path, me to him, was an S1. And that was me just running a couple of watts.
But lower symbol rate, you can reduce your bandwidth and come down to VHF and then get in easily.
Yeah, you can.
There you go.
Yeah, and so people are even going down on 50 megs now, 50 megs and transmitting this. But we've managed to get it to work on 70 cents. We thought about 50 megs. I haven't got any 50 megs equipment, and you might think, well, yeah, okay, it's a lower frequency, but then you need a much bigger antenna, and
6 metre beams aren't that uncommon.
Yeah, but no, we thought, because we tried. We didn't try the TV, but we tried on it. A friend of mine just up the road's on 50 megs, so I went up to his house. I had a chat with John on 50 megs, and it's still a bad signal, right? So it was doubtful whether it was going to work on TV. So because we've got high gain antennas on 70 SEMS, we can sort of compensate to a large extent for the frequency, and we managed to get a signal through. If there's time, I don't know if you've. What do you want me to do? Do you want me to carry on a little bit longer, but not too much? Good. I've got some video I can show you. But the trouble is, because we haven't got the PA connected, we won't get any sound. Bad, but never mind. I'll tell you what we said.
Can we turn your laptop up high, up loud?
No, the audio won't come out of the laptop.
You'll have to try that connection
because the audio is all going out on the HDMI and it turns it off on the laptop.
Shall we give this one more try?
Yeah, let me just cue up the video. I've got a couple of videos on here. Not that the sound is that
You know signing, don't you? Auslan?
No. Okay, so it was that cable. We'll try with your cable. This is still turned on.
Still on. It's your box not working then.
2 channel, 5.1 channel, pass, no, that's audio.
No, shouldn't matter.
No.
When in doubt, give it a cloud.
Oh, I heard it.
Where's Bell? He knows that technique.
No,
No, no good.
No good.
Right, I'll put it back. I thought it was worth one more try.
yeah, yeah.
Worth a try. Because it worked last time.
Cool. Okay, so this is the first time this has been done in Sydney, to our knowledge, and this is this contact that we had. So the first way that we did it was from me to John. So I'll let this, see if this video will come up, and I'm going to hit the pause.
Stop it 18 kilometre path.
I'm just going to hit the path. I'm going to hit the pause button on the path, right, so you can see how bad this is. This is me. This is me over here in Ryde. This might not look much, but this is really important. As you know, these close-up obstructions, they're the real killer. And I've got a beam right through a hill that's very close to me. And he's got 2 hills in the way. No, 3. Got 3 in the way. Right. How's it possible?
What's
Well,
on those hills is the question.
yes.
Because then, like, if it's hitting anything the right length, anything that resonates re-radiates.
Yeah.
And that's how signals get around here.
Yeah. So it's interesting you say that, because the way that you can look at this is when it gets to this hill, if you get some knife edge diffraction and you're going to knife edge diffract over this, you're relying on a signal that is actually following this path to get up to here. When it gets up to here, it does that. And when it gets to there, it sort of does that.
If we hit the top of that first hill, the second hill.
Well, can it? Yeah, if there's a path, yeah. Does it
If you've got any 12...
No, it doesn't. You see, it can't get through. Right? It has to diffract at this point
Twice.
as well.
It's got to go twice, doesn't it?
Yeah.
3 times. Though.
Yeah.
How wide are the hills?
The point is you've got to have some 12.5 centimetre features to resonate
Yes.
waves.
Yes.
And if they resonate with the signal, they're going to retransmit it in a different
Yeah.
direction.
Yeah. Yeah.
The only 12.5 centimetre magpies and kookaburras
Yeah,
sitting on a tree.
pine needles. I mean, 70 centimetres is impossible to fox hunt in a pine forest because all the pine needles absorb the signal. They're all the right length and they're resistive, so they
Okay.
absorb the signal. Six metres is impossible because the trees are 6 metres apart.
So, what's happening here is, oh, okay. So I'm just running a little bit of video while we do it as a test. So he's receiving it. He's streaming it back to me via BATC, which I'm then getting on my laptop. So what you can see in the background, you see how weak the signal is. It's there though, and it's not zero. We're getting a few dBs above the noise, which is enough to get a picture through. So this is 333 on 70 centimetres now, and it's 720p, so it's half HD. So it's not too bad. We were pretty happy with this. Because when we started this, we thought we're never going to get a signal between ourselves because we can't even talk to each other direct on 2 metres. We've always had to go through the repeater. So, but when we did a test on 70 cents narrowband, what I did, I looked at the signal from him on my SDR, and I could work out from that. This is what we were getting with an FM signal. If we scale this out now to 333, we can work out what the signal to noise will be for the TV signal if he runs the same power. And then we could work out, yeah, this should work. And it does. Yeah, so what you can't hear is me getting really excited when this worked. But I've actually... Because the quickest thing for me to do was just point the camcorder at the laptop, but when I sort of got settled down a bit, I'll wind it along a bit. Okay, this is direct off the computer screen now, recorded. So we were getting a bit of interference, unfortunately. He does have a bit of QRM down there, so this occasionally would drop out completely. Yeah, that's John VK2CRJ over at Revesby receiving these pictures. And what else? I'll run it along to the end. Oh, okay. And there we are. There's me in the shack, talking to him on the phone because I couldn't talk to him on 2 meters. But we still got a picture through on 70. Yeah, that was good. I've got another one which is a few weeks later. We tried the other way around. Now, he used a DTX1, which is that transmitter over there, and that will go down to 1 mega sample per second. So there's a bit of a penalty there. You've already seen that. So it's roughly speaking 3 times more bandwidth than the signal I was sending, but he was able to transmit more power than me. So he managed to compensate to some extent. So, but this is MPEG-2 now. So I was running H.265, so my picture quality was much better than this because that DTX1 over there will only do MPEG-2. But there's John ATU in his shack with a rather lot of blocks in the picture due to the not very good image compression. But whatever, it's TV with moving pictures.
And there's the signal shape.
Yeah, there it is on the spectral analyzer.
Which we had on the other spectrum analyzer here before, but
Yeah.
then Tim fixed it.
Oh. Oh. Has that stopped working, that other one then?
Working. I did get the signal looking like that.
Yeah. This is that SDR Angel software, by the way, which has got this DVB-S demodulator in it. The one that doesn't work all that brilliantly, but it does work when you get a strong enough signal. You can see the constellation on it there. But I was not sure what I was. Yeah, I was probably. No, I was getting his. That's the mini tuner over there with his picture on it. But you can send a UDP stream out from the SDR Angel software, so that's the better way of doing it. Actually, I've found when you try and use the internal viewer, sometimes quite often it stalls. But you can get the UDP stream out of it, then you can send that off to something like FF Play, and you can watch the pictures on that. Works a bit better. Yeah. So what it says is now yes, that was magic that I managed to capture that aircraft flutter or some sort of multipath. Yeah.
Really?
Yeah. Well, we're not an online of sight path, right? If an aircraft gets in the way, we're going to get a really good signal.
And you see the way the different frequencies cancel. And
Yeah. Oh, okay. So there we go. So that's John. You see, it's coming off a UDP stream now. So that will be either from that one or yeah, it's that one because it's got the same IP address on it. So it does work. But I suppose the message from this is, if you try hard enough and you go down to a narrow enough band, you can get a picture across an absolutely atrocious path. So it's worth having a go. All this crap up here, by the way, this is 445.5. It's the third harmonic of the clock that gets used on HDMI. Yeah. Unfortunately, I've got a lot of that in the shack, so that's why we had to move down here. Normally, our TV repeater, when it was on, because it was 7 megahertz wide, so it would have been this wide, this wide compared to that.
Oh, I love seeing that.
Yeah,
that's great.
It's good, isn't it? Oh, it looks like it wasn't very happy when that happened. We've lost the signal now. hopefully it will come back eventually. Oh, I think that's the same thing, just going round and round again. So, what I'm interested to know, because I want to ask you some questions now, has this got anyone fired up in this club sufficiently that they're interested in having a go at some ATV? Thinking about it. What?
A lot of things I've got to do before I do that.
Yeah. Yeah.
So what do you need for the repeater?
A site.
A site.
And somebody to operate it.
Yes.
Oh, you need somebody to operate.
No, you don't need anybody to operate
Yeah,
it.
you need somebody to install it and maintain it.
Oh yeah, of course.
Yeah. But do you need like a big tower or?
Preferably.
You need a line of sight.
As good as you can get, right?
We're a little bit over the side of the hill on this side here
Yes.
from being able to see into Sydney.
Yeah.
Even just a little bit, a few hundred metres up that way,
Yeah.
go on top of the hill.
I've
Kind of on the back
I've
side.
done a path plot from here to my house, and it's line of sight to me until it gets to that local obstruction.
There you go.
So I reckon it might work for me from here, but we'd have to try it out.
To there from here,
And
to
well,
here from there.
it'd work either way, right? Potentially. I mean, if you're interested in trying it, at least we could bring some gear up here and try and send a signal out from the club here and see if anybody can pick it up.
That
But
sounds like a great idea.
we'd have to get some antennas up the tower. I don't know what you've got up there already. Have you got?
We've got another tower coming up.
You got UHF?
We have a spare tower at the moment. We haven't done much of
I saw one lying around outside.
We've got a hole in the ground up there.
Yeah.
Yeah.
Well, that's already 10 metres,
That-
a few metres higher.
Yeah. I mean, trying it here would be a great idea.
So we can probably rustle up, or somebody can rustle up a 70 cent beam from somewhere. I can see you've probably got one up there.
Yeah. But that belongs to Nick and he takes on field days.
No, it belongs to the club. It's the club.
I know, they belong to the club.
Yeah, I know that.
The whole of Nick has belongs to Nick.
Yeah.
Yeah.
So as a
Try.
worth a try as a temporary installation. Now, but I have had a listen to is it VK2RMB, isn't it?
Yes, yeah.
Your 2 metre, you've got 2 metres and 70, and your 2 metre repeater in ride is pretty weak. I've tried it, but we've seen before that 2 metres, because you're only going to be on a low gain antenna probably on your 2 metre repeater. Relative, is that right? Is it just a vertical of some sort?
Yeah, it's about 60 dB going on.
Yeah. So once you get some gain on the antennas, especially on the receive side, then you're sort of in with a chance. So
But that RMB is on a 100-foot tower,
yeah,
and it's higher than here.
yes.
Are you home? Is your home higher than here?
Yes.
Have you got a tower up here?
At my place?
Yeah.
No, I'm lower than here.
Yeah, lower than here.
Yeah.
I
Now,
thought you were quite near the temple there, which is pretty
Yeah,
high.
the other side of the hill.
Yeah, okay.
the funny thing is, I've done a path plot to that repeater, and it's worse from there than it would be from here to my place. So it's worse. I haven't got all the path plots with me. I've got them all at home, loads of them, because of course we've been trying all sorts of.
It's a bit of a hollow.
Yeah.
We'll be shooting down the valley.
Yeah, pretty
Yeah,
much.
right.
I think it's better from here actually. You might be higher over there, but it's not as good.
No, that's right, because there's higher land.
Yeah, yeah. I think the trick here is just to get over the trees. If
No,
you-
from here you'll shoot past Pimble, whereas from there
Yes.
you shoot straight through Pimble.
Yeah. Does your HF tower does that look over the trees, or is it at the tree height?
And,
It sort of looked a bit marginal. You look, yeah,
There's big trees here.
yeah. There's big trees. That's the issue, isn't it? It always is.
Who wants to go to soccer school?
oh yeah,
Hmm?
yeah.
3-1 to England.
Oh.
No.
Yeah.
Dire.
Well,
Go on, stop smiling.
I thought-
We saw the smile.
yeah, I know. I can't help it. Look.
At least pretend you're upset.
Yeah. Bugger. All right. No. I could have put it on the Dick Smith TV, but I thought I better not do that. You'll be watching that all the time.
Look, at the end of the day, we can try from here.
Yeah, give it a go.
The theory,
So
the
let's
practice.
have a chat about. Well, this is what we found, right? Because these path plotting softwares, they're not always all that accurate. You just have to try it at the end of the
I
day.
reckon if you want to know whether there'd be interest, if you run the trial,
Yeah.
and a few other people are not here might become interested.
Yes.
Yeah.
I think.
So, what, make a day of it one weekend, or what's the theory?
Have to ask our president.
You know, the biggest problem for me running TV was Monday nights, and I've been playing tennis since high school days on Monday nights.
Oh.
I'm still doing it. But,
Well, that can be fixed.
What, just me happy?
back in the analogue days, Ashley Anderson had a set up at Kings Lake, Winston Hills, where he lived, and I put another TV antenna at my place and pointed it up to Lawson. So
Yeah.
people transmit his TV pictures to the repeater device, so I can pick them up on a
Oh, yeah.
TV home.
Okay.
You have to have an extra antenna pointing up to Lawson, because my other antennas are pointing to the city, so
Yeah.
Sorry.
it was just
But that was back in the analogue days where they had the ACMA had that drop through, that strange thing they called the drop through provision,
Oh.
where they allowed animals to transmit on, what was it?
Channel 5.
Channel 35 or something like that.
The drop through was in the,
And if you drop in,
Yeah.
42 or something, channel 40.
35, I think.
35?
Yeah, that was before I came here, but I heard about that. So it was sort of 500 and something megs. It was a bit above the normal 70 sem band. Yeah, that would have been, that was magic, because I mean that meant you could do a 70 sems sort of effectively UHF in, UHF out repeater, which is the best way to go really. But we lost all of that. I think it was Olympic Games, wasn't it? Came along in 2001 and they said we want the frequencies.
The whole band stacking of the
Yeah.
provision, like everything got shuffled around there.
Yeah, yeah, yeah.
That was the end of
there's obviously a lot of
the drop
computers
through
off
provision.
Yeah.
the USB instead.
Yeah. Yeah. Anyway,
Gary, and I think we need to organise a time, figure out how long it's going to take to actually do the experiment, set it up,
And
what
what's
we need to do,
required.
what we need to do beforehand.
yeah,
What kind of
basically,
people might
you've got to get a 70 cent beam up the top of your tower, haven't you? That's pretty. Yeah, yeah. The rest of it's easy after that.
Yeah, so once you get a cable,
Yeah,
and the beam up there, that's just half the battle, isn't it?
yeah, because we've got the antennas that we used to have up at Lawson, big antennas that we.
Just the beams enough, or do you want
But-
a panel? You don't want a panel reflector or something to.
Oh, now that's interesting. What have you got up there then?
I don't know, there is one.
I can see some sort of
No, I think the only 70 centimetre we've got is that long beam. I don't think we've got any panels.
no. We've
The only panel we've got is on
Panels that
through
reflect
the
can help.
yeah. No, we've got a big panel antenna that we used on 70 sems and 23. But well, it's up in the Blue Mountains. We're not moving it until we're certain we've got a site and if we can do anything with it. But a normal Yagi just for trying it out will be good to start with, just to see if it's
See if you can
got any chance
See if you
really.
can get through the local trees.
Yeah, yeah,
Drive
Thank you
down
very
the
much,
road.
Karen.
yeah.
Very interesting.
Okay, thanks.
Getting old. See you, buddy.
See you later. Cheers, guys.
See you later, Carl.
How long have you been coming?
And I'll just get this little receiver.